reliable and giving us the consistent results. Now moving towards the next and last one, that is the internal consistency reliability. This reliability tells us up to what extent a test is internally consistent, or what extent there is a good amount of balance or correlation among the indicators or the dimensions of construct. So for explaining this, I am taking the help of a diagram. I think you are able to see a slide. I am showing you a diagram here. I have taken
Yes,
here a
ma'am.
construct. Construct is happiness. Suppose I want to measure the happiness. So happiness will be the construct. So to define happiness, I have taken here 10 indicators. These can be the indicators or items. Means these are the questions which will reflect the happiness. Suppose question 1 is stating, I feel happy. That is first question. Second is, I smile oftenly. Next can be, I feel positive frequently. So these type of question we can keep in the indicators, and these are known as indicators or items. So these can reflect the happiness. And suppose if I calculate coefficient of correlation among these items, and if the coefficient of correlation value is high enough, then we can say these indicators are capable enough to indicate or to represent construct happiness. They are able to give the true happiness calculation for a particular individual. And this way we can say the scale is reliable enough. So this is known as internal consistency reliability. Now, how we can measure internal consistency reliability? It is measured with the help of Cronbach's alpha. This is given by an American psychologist, Ray Cronbach, in the year 1951, and this measures the inter-item reliability or internal consistency among the items of a scale. This can be measured with the help of a coefficient. The main advantage of Cronbach's alpha is that it is very helpful for continuous variable and dichotomous variable both. In that means in case of continuous variable we can calculate the Cronbach alpha, and even in case of dichotomous variable we can calculate the Cronbach's alpha. Now what is dichotomous scale? Dichotomous scale mean when there are two items only in yes and no form, in right wrong form, or in correct incorrect form. So that is known as dichotomous scale, when there are only two options available for giving answer. So that is known as dichotomous scale. So we can calculate the Cronbach's alpha in case of dichotomous scale as well. Then in this slide you can see there are formulas are given. With the help of these formulas we can calculate Cronbach's alpha manually. First method is variance method, second method is correlation method. And these are the formulas. With the help of these formulas we can calculate manually the value of Cronbach's alpha. But when we have software, why we will take such pens for calculating Cronbach's alpha value manually? So I am moving towards the next slide now. This slide will show you the interpretation of the Cronbach's alpha. I am moving from bottom. At the bottom you can see the alpha value is less than 0.5. So this value indicates us that the scale is unacceptable. That is this value shows us the unacceptable reliability. That means we cannot accept the scale because it is not consistent enough. Then if alpha will lies between 0.5 to 0.6, we can say there is a poor reliability in the scale. If alpha lies between 0.6 to 0.7, we can say the reliability is questionable. Please keep in mind, if it is in between 0.6 to 0.7, we can say it's a questionable reliability. We cannot rely on the reported alpha value. If alpha value is in between 0.7 to 0.8, we can say we can accept the scale because it is giving us, or it is able to give us consistent results. If alpha lies between 0.8 to 0.9, we can say reliability is good. And suppose if alpha value exceeds 0.9, we can say it's excellent reliability. But I will suggest you, if in any case your scale is reporting 0.9, that is excellent reliability, then that is not a good sign. because it can lead to the multicollinearity. So what is multicollinearity? That means there are some items which are highly similar and they are highly correlated. So this way they are not able to distinguish between each other's effect, and this situation is known as multicollinearity. So the suggested range for convex alpha value is 0.7 to 0.9. If alpha value comes in between 0.7 to 0.9, we can say our scale is reliable, and we can get the same result every time when we will conduct the test with the help of this scale. So what we can do to reduce the reliability if the alpha value is greater than 0.9? In that case, what we can do, we can check the inter item correlation value. That means if two items are highly correlated, then we can remove those two items from our scale or any one item from our scale to reduce the alpha value. So this way we can reduce the convex alpha value. Now in this slide you can see the process which we can follow to calculate convex alpha in SPSS. So now I am moving towards the SPSS window. Now I am opening here a file. You can see how I am importing the file here. There is one way we can go to the file menu and then open and then data. But I am coming to the recently used data because recently I have worked upon that particular file. So I can see here my file will be here maybe. So I have opened my file. This file is indicating us the customer satisfaction towards restaurants. With the help of this file, I am going to show you how we can calculate Cronbach alpha. So what is the process? We can click to the analyze menu. Then we will go to the scale. Then select reliability analysis and then OK. Now I am forwarding all the question of the scale to the items window. There are two ways to transfer these items to this particular window. First one is I can use this particular arrow. Maybe you are able to see. If I will click, these items will be shifted here. Otherwise, second thing is I can drag and drop here. You can see I have shifted all the items with the help of dragging and down help method. Now you will see in this dialog box, model is alpha, which is required by us. Now we will click on statistics. In first box, that is descriptives for, click on item. Item will tell you each item, that is each question's mean and standard deviation value. Then click on scale. This will give you overall mean and standard deviation of scale. And at the end, scale if item is deleted. This is the important one because it will indicate us that if particular item I will remove from my questionnaire, so what will impact come to my Cronbach alpha value. Then click on continue and then OK. So now in output window, I hope you all will be able to see the output window.
Yes, ma'am.
Yes, ma'am.
Yeah. So here first table, that is case processing summary. What this table tells us, here you can see there are valid cases 121, excluded cases 0. That means there is no missing value in the data set. That is why all the cases are treated as valid cases. So this way the percent is 100%. So this is the interpretation of this table. Now we are moving towards the next one. This table indicates you the Cronbach's alpha value. I think you people are able to see the value of alpha is 0.672. So 0.672, what it indicates?
Is it average?
No, it's a
Questionable.
questionable reliability. I think
Questionable.
I'm showing you in a PPT again. Yeah. Yeah. Here you can see if
Questionable.
alpha value is 2.6 to 0.7, then we can say it's a questionable reliability. So that means we cannot accept this reliability. So in that case, what we can do? So we need to do some analysis. Can we improve the reliability? Yes, we can improve the reliability, but how we can improve the reliability? For this, we need to see the next table, that is the item statistics table. Here you can see all the questions are listed here, all the 31 questions are listed here, and mean value, standard value, item wise given here. So when we will analyze the mean value, we can see here those items whose mean value is nearby 3, these items can be problematic for us. Why so? Because this is the 5-point Likert scale, and in 5-point Likert scale the middle point will be 3. 1, 2, 3, 4 and 5. So 3 will be fall in between the scale. So 3 will be, what 3 indicates us? Anyone can tell me what 3 indicates us? In last
Neutral.
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 Neutral, madam.
Yeah, they are not, and this they are midpoint of the. So in this, please your microphone off करिए, please switch off your microphone. Yeah. Now, so this means those items whose value is nearby 3, that is 2.98 like this. These are the problematic items and they are not able to take proper response from the respondents. So we can remove this question, that is the one way. Similarly, we need to check the standard deviation value. There is the highest value is for standard deviation. Highest is 1.4 something, I think. Yeah, 1.47. No, it's 1.52. The highest 1.53 is the highest one, and the lowest one is 0.849. So it again indicates us there is a problem with items because this should be around 1. Standard deviation value should be around 1, but it is ranging from 0.9 to 1.5. So it indicates that there is a problem with some items. And finally, we can see in the third table, that is the item total status table. In this table, you need to see the fourth column or the second last column. And this column is labeled as corrected item total correlation. So in this, you need to check the item total correlation value. If it is negative, we cannot accept it. So you can see here, there are few questions whose item total correlation is negative, and that is in case of question number 23 and question number 24. So what we can do in this case, we can remove these 2 questions, first of all, to check whether there is any difference on the value of alpha. So again, I am going to the analyze scale and reliability analysis. Then I will pick question number 23, select question number 24. Then I will send back to their places, and then I will don't touch anything, and then clicking on OK. Now you can see here I have removed 2 questions, so total items are now 29, and now you can see that the alpha value is increased. It is now in range. It is 0.7 now. Again, we will go to the third table. We can see here. Now there is no item with the negative item total correlation. But there is one more thing which I need to tell you. Here you can see I am again showing you the slides. In slides, you can see item discrimination index. What is this index telling us? This index telling us that those items whose item total correlation is less than 0.4, we cannot accept those items for the analysis purpose, but in some cases we can take it as a point 2 as well. So again I'm going back to the output window, and again I'm checking there are few items whose item total correlation value is less than 0.2. So I'm starting from the least value. You can see here first two items, that is Q1 and Q2. In these two questions, the item total correlation value is 0.041 and 0.032. So this is very less. Again, we can remove these questions, and again I am going to the scale and then analysis. Now selecting Q1, Q2, sending them back, click on OK. Now there are total 27 items, and see there is an impact of removing two questions. Cronbach alpha value is improved little bit. It's now 0.708. So this way we can check and we can remove an acceptable range for total item total correlation is you can take more than 0.2, but generally it is suggested it should be greater than 0.4. So this way we can improve our reliability or the Cronbach alpha value. So this is the first part of the presentation. Now I will again coming to the presentation part, and now we will discuss about the normality. So what is normality? Normality is a certain kind of shape that is bell shaped. If our data following certain distribution, that is bell shaped distribution, then we can say the data is normal. And there are some characteristics, some features which are telling us that the data is normal or not. First case is mean should be 0, standard deviation should be 1. If mean is 0, standard deviation is 1, we can say data is symmetric. But there are other assumptions as well, and these are skewness value should lie between +2 to -2 range, and kurtosis value should lie between the range of +3 to -3. And generally it is known because we cannot achieve zero mean, because we are working generally with the Likert scale, and for Likert scale, if we are using 5-point Likert scale, so we will give coding 1, 2, 3, 4, 5. When we will add these 5 number and divide this by 5, so we will get 3. That is the middle value, middle terms value, or the middle item value, that is 3. So we can say we cannot achieve zero value in any case. So safer side we can say if mean, median and mode, all three values are similar enough, then we can say the distribution is normal. Then there are different methods to check the normality in SPSS. First one is the histogram. Here you can see I have kept a image here of histogram. There are two different type of histograms in the image. First, in the first image, on this I am moving my cursor. You can see here this histogram diagram and this curve. This is the bell-shaped curve. So this histogram diagram is showing us the data is normal enough. But here, if I am talking about the second image, in this image, if I am putting the bell-shaped curve, in this particular image, you can see that the data is not normal, because you can see there are so many data units or data points which are lying beyond this particular shape. So this way we can say that this image is not the normal image, but this is quite, or this is intending towards the normality. Now how we can see the normality in SPSS? So with the help of histogram, again I am going to the SPSS window. Now I have taken here some other data set. You can see here this data set is of car sales data set, and variables are manufacturer name is given, model number is given, sales, resale value, type, price, engine size, horsepower. There are different types of variable are given. We can go to the variable view to see all the variables here. You can see there are different types of variable, and the different measures are used to describe these variables, and the nominal, scale, ordinal, every kind of measures are used for in this particular data set. So suppose I want to check the normality of sales in respect to the type of, first of all, I need to check here what is the type. I'm clicking on the vehicle type, the value. Here you can click, you can see 0 indicates the automobile and 1 indicates the truck, means type of vehicle can be truck and automobile. So suppose I am going to check the normality for sales in context to the type of vehicle. So again I am going to the, now you can see here, because histogram is the graphical method, so we need to go in the graphs, then click on the legacy dialog and then check, then select histogram. Now here whatever variable we want to, for whatever variable we want to check the reliability or normality, we can select that particular variable and shift to the variable window like this way. And we don't need to touch any of the option, and just on clicking, we can see the output. I'm just showing you the output. It is loading here. Here you can see, this is the histogram. What histogram is indicating? Suppose I am inserting here the bell-shaped curve here. So I can insert that with the help of legacy dialog box. I am again going to the legacy dialog, then clicking on histogram. Then you can see here there is a box that is display normal curve. I am just checking this box and then clicking on OK. So I am again going to get one more histogram here. Yeah, you can see here, this is the bell-shaped curve. Now you can see this particular distribution of data is indicating me that is this data set is skewed. It is not normally distributed. Further in coming slide, I will let you know what is the skewness and what is the positive and the negative skewness. In further slides, I will show you that as well. So for reference, I am saying you this is the positively skewed distribution. So that is the one method to check the normality of the data. Second method, I am going to the slides again. Now you can see second method is known as box plot method. Here you can see there is a box plot. In this box plot, the thick line between this box is indicating us the median value of the data. Then the upper line of this box is indicating us the third quartile. Lower line of the box is indicating us the first quartile. Then these are the whiskers. This is the lower whisker, which indicates as the minimum value of the data set. And this is the upper whisker, which indicates as the maximum value of the data set. And here you can see some circles. These are the outliers. Outliers means these data sets are very away from the remaining observation. These data points are away from the remaining data points. You can see in the next slide. I have showed you how we can understand that particular data point is outlier. You can see most of the data points are falling in particular range, but these two are the extreme points, or these are known as the outliers. So this way we can say this box plot is also the indicator of normality. Now how it is a indicator of normality? Suppose if this median value falls within the box, we can say the distribution is normal distribution. But suppose this line shift either upwards or downwards, in that case, if it goes upward, we can say the data is negatively skewed. If it comes downward, we can say data is positively skewed. So this way we can check the normality of the data with the help of box plot as well. Next method is the Shapiro-Wilks test method, that is SW method. In this method, the sample size should be less than 50. Next one is the KS test. In this test, the sample size should be greater than 50. But there are different opinions of researchers. Some says we can deal or the Shapiro Wilks test can deal up to the sample size of 2000. And generally this is that is KS test that is used for the larger sample size, but this is the opinion of different researchers. I have seen so many papers. On the basis of that, I have written here the sample sizes, which you can see here. For SW test, the sample size can be less than 50. For KS, sample size should be greater than 50. The way to calculate or check the normality with the help of these two tests is we can go to the analyze menu, then we can select descriptive statistics, and then we can go to the explore. And thumb rule for accepting or rejecting the hypothesis of these two tests. What will be the hypothesis in these two cases? The hypothesis will be that data is normally distributed. That will be our null hypothesis. If suppose after calculating, after applying these two tests, the significance value is less than 0.05, then we can say we are unable to accept the null hypothesis. And the null hypothesis is the data is normally distributed. So we can say the data is not normally distributed because significance value is less than 0.05. So this is the interpretation of these two tests. Further, there is one more way of testing the normality, that is the we can take help of central tendency, measures of dispersion, and measures of distribution. In central tendency, you all are knowing mean, median, mode are coming. In measures of dispersion, we can take the help of standard deviation and variation or variance. And measures of distribution, we can take skewness and kurtosis value. But how we can do all these things? For that, I am again going to the SPSS window to give you the practical exposure. So now I'm coming to the analyze menu, then going to the descriptive statistics, then selecting the explore. Now a dialog box will appear. Here I am transferring two variables, that is sales variable and resale variable, in the dependent list and vehicle type in factor list. My purpose here, I am interested here in finding out whether the average sales price of automobile is higher than the average sales price of truck or not. Similar is applied for the resale value as well. So for this, I need to go to the statistics here. You can see the first dialog box is checked. So keep it checked, then continue. Then you can go to the plot. Here, three options are already by defaulted checked by the software. Don't need to touch them. Just click on normality plots with test. Then continue and then OK. The output will load in few seconds. Yes. Output is loaded now. Here output is loaded. Now, we will see the interpretation of these tables now. First table, that is case processing summary. In this table, we can see there are two main variables, that is sales and resale. And on the basis of type of vehicles, that is automobile and truck, we have calculated all the things. You can see here in case of type of automobile, there are 91 valid cases and there are 25 missing values. In case of truck sales, there are 30 valid cases and 11 missing values. Similarly, we can read the second part of the table. Now, second column is indicating us the percentage. How can we calculate percent here? So, we can calculate percent here by 91 into 100 divided by total is 116, 116 and then equal. You can see that is 78.4. This is the percent. Similarly, 30 divided by 41, we will get 73.2%. So this way, we can interpret the table number 1. I have explained you part 1. Second, we can, I think you can explain by your own. Now I am coming to the descriptive
Ma'am, please
table,
repeat how
that
you
is the
opened the
main
Explore
important table.
status.
Statistics and then explore. Got it?
Thank you,
Analyze.
ma'am. Yes, ma'am.
Okay, okay. So now I am coming to the descriptive statistics table. This is the important table. This will also help us to check whether the data is normally distributed or not. So the main variables, that is sales and resale, you can see here. Then sales of automobile, all the calculation is for sales of automobile here, and the sales of truck here in the next part. And similarly, resale for automobile, this is the resale for automobile values, and these are the resale for truck values. Now, coming to the first part, how we can interpret this. You can see here, first is indicating as the mean. Mean is indicating as the average sales of automobile is 46.8950 to, I think unit will be, unit is thousands of dollar. I think the unit will be thousands of dollar. So we can read it as a mean sales for automobile is 46.8950 to thousands dollar with 5.522076 standard error. That is very simple to interpret. Now moving towards the next one, that is the important one. It is indicating as the 95% confidence interval for mean. So this is giving us a range of mean. That means in case of 95%, in 95% cases, the mean sale for automobile will lie between 35.94452 to 57.86559. The range, you can see the range is very huge. This range is huge because the standard error is good enough. So that is why this range is high enough. Now you can see here next is indicating as the 5% trimmed mean. Now what is 5% trimmed mean? As name itself suggests, there is trimming is done. And what is the trimming? That means the outliers from the data set is removed in case of automobile, sales of automobile, and then the mean value is calculated. So after that calculation, the mean value, reported mean value is $39.79046,000. So you can compare the mean, actual mean value and trimmed mean value, 5% trimmed mean value. You can see there is a huge difference. Actual mean value is 46, but the 5% trimmed mean value is 39. So it is indicating us that data is not normally distributed. There is enough gap. There are so many outliers available in the data set. So that is the interpretation of the 5% trimmed mean. Now going towards the next one, that is the median value, and that is again 27.85100. So in case of median value, again, as I had discussed in case of when I was showing you the PPTs, that the mean, median, and mode value should be almost equal if we want to if we want data should normally be distributed. But you can see here the mean value is 46 point something and the median value is 27.85. There again there is a huge difference. Again it is indicating us that data is not normally distributed. So this way we can say data is not normally distributed. Now next we have variance and then standard deviation. There is a relationship between variance and standard deviation. When we square standard deviation, we get variance. So if both the items, that is variance and standard deviation, are interlinked with each other, then what is the use? Why we are reporting both the things? So please keep in mind the purpose of reporting variance and standard deviation is quite different. If you are reporting variance of the data set, that means you are stating the variability in the data set. If you are reporting standard deviation for your data set, you are indicating the spread of data of scores from mean. Means how far or how away, how the data scores are spread away from the mean value, that is known as the standard deviation. So the purpose of reporting standard deviation and variance both is different. Then next one is the minimum. Minimum is indicating the minimum in case of automobile, minimum sales value is 0.110 and the maximum value is 247.994. Range, I think it is known to you. Range is the difference of minimum value and maximum value and minimum value. So we can subtract 0.110 from 247.994. This way we will get the range. Next one is the interquartile range. Interquartile range is an interesting thing. So I am coming to the PPTs again and showing you the interquartile range first. I think you are able to see the slide. Here you can see the interquartile range. Suppose I have first of all, I have arranged my data set in particular line. Now you can see there are two terms interquartile. So first up, I am concentrating on quartile. Quartile divides a particular scale into 4 equal parts. You can see here from 0 to 25% it is Q1, from 25 to 50 it is Q2, from 50 to 75% it is Q3, and 75% onward there is remaining data scores. In the same way, you can see here, if I take percentile in a ascending order from P0 to P100, so P25 will be equal to Q1, that is quartile 1 is equal to 25th percentile, quartile 2 will be equal to 50th percentile, quartile 3 will equal to 75th percentile. And you can see this is the minimum value here and this is the maximum value here. And what is the formula of calculating interquartile range is P75 minus P25, that is 75th percentile minus 25th percentile. So what interquartile range indicates us? Interquartile range indicates us the spread of scores in data set. Means this is again indicates the variability in the scale. Larger IQR in group indicates greater spread of score or greater variability in the data set. So again, I am coming to the SPSS output window. Now you can see here interquartile value. The interquartile range value in case of automobile sales is 53.230. So I can compare these two values. That means the interquartile range value for automobile sales and for truck sales. You can see here interquartile range value in case of automobile is 53.230 and in case of truck it is 108.641. You can see that is just double. In case of truck sales, it is just double. It indicates there is variability in case of truck sales as compared to automobile sales. So this is the indication of significance of interquartile range. We can confirm this with the help of standard deviation as well. Standard deviation is 52 in case of automobile sales and in case of truck sales it is 111. That is almost double. So both interquartile range and standard deviation are narrating us the same story. Now moving toward the skewness. So before explaining you skewness, I will again coming to the PPT part and will first show you what is skewness is. So here you can see skewness is a measure of asymmetry in the distribution or in the data. It refers to the deviation of scores from mean score or from measures of central tendency. It is generally a horizontal deviation. That means you can see here there are three graphs I have shown you in the slide. The middle one is the normally distributed graph. There is no skewness. There is symmetry in the graph. There is lack of symmetry. That means there is no skewness. Skewness is zero in case of normal distribution curve. So you can see second graph is normally distributed, but the first and third is not normally distributed. In first image, you can see the left tail is long enough. It indicates us that the data is negatively skewed. Similarly, in the last graph, you can see the right tail is long enough. So this indicates us that the data is positively skewed. Again, if the scores are in the positive sign, we can say the data is positively skewed. If the skewness value is represented by negative sign, we can say that the data is negatively skewed. So I am coming to the SPSS output. Now here you can see in case of in case of sales of automobile, the skewness value is 2.156. This is a positive value. That means we can say data is positively skewed. And we can say that the sales of automobile is positively skewed. Similarly, we can check here in case of truck.
Madam, your PPT is not visible.
Sir, I am showing you the output window of SPSS.
No, it's not visible, madam.
Somebody share their screen, so your screen has been gone, ma'am.
Okay. Again, I am stopping and again I am sharing.
Okay.
Yeah.
Please ask the participant do not present their screen, ma'am.
I think somebody is presenting already.
Please message.
Somebody Math RQ's name. He is presenting their screen, ma'am.
I request
RQ.
whoever is going to or trying to show their presentation, please stop.
Math Achievers. The person's name is Math Achiever. He is presenting the screen.
Is presenting the screen.
Math Achievers, please click on present now.
Priyanka ma'am.
Again.
Priyanka ma'am, are you here?
And now you can present your PPT.
Now you can present your screen, ma'am.
I can. I am doing. I think now you are able to see.
Yes, ma'am. Yes.
Yeah. So yes. I was explaining you skewness. Here you can see in case of automobile sales, skewness value is 2.156. It indicates the value is positive. So that means there is a positive skewness in the distribution in this particular data set in case of automobile.
Excuse me, ma'am. We can't see your PPT.
Ma'am, I am showing you the SPSS output.
It can't be seen, ma'am.
Oh my God. Again, I think somebody is...
But now, what is you presenting?
Now I think you people are able to see.
It is coming, ma'am.
Yes, ma'am. Okay. So I was explaining you the skewness. Here the skewness value in case of automobile sales is 2.156. So
no, ma'am, can't see.
Ma'am, there is a problem. Like,
sorry,
I think you
are
need to
not
minimize
presenting
the screen and show the PPT again. What I can see is like the window, like of your like where you're opening up the app. That is what is showing, not the PPT.
Yeah.
Ma'am, it says you are presenting to everyone. Only that initial screen is there.
Yeah. I am again trying to share one more time.
Ma'am, please on your PPT.
Yeah. Wait. I hope now you can see.
No, madam.
Yes, ma'am.
Yes, ma'am. Yes, ma'am. Yes.
Yes, yes.
Yes, ma'am.
Yes.
So can I start?
Yes,
Can
it's
I start
starting.
now? Yeah.
Yeah,
So
madam.
in
You
case
can start.
of sales, in case of automobile sales, the skewness value is 2.156. This is the positive number. This indicates us that the data is positively skewed. If there is a minus sign with this particular number, we can say that the data is negatively skewed. But there is no negative sign, so we can say in this case, in case of automobile sales, the data is positively skewed. Then, similarly, in case of truck sales, skewness value is positive, that is 2.567. So we can say that the data is positively skewed in case of truck sales as well. And we can interpret that because the skewness value is positive, so we can say that the automobile sales is more than the average value, that is 46.89502. Similarly, in the case of truck sales. But we can check with the help of this skewness, we can check whether the skewness is significant or not. How we can check that? Again, I am coming to the PPT. You can see we need to calculate the significance level of skewness. And what is the formula of calculating significance level of skewness? Formula is the value of skewness divided by its standard error. You can see here there is skewness value that is 2.156 and the standard error value is 0.253. So I'm using the calculator here, clearing all these things and entering the skewness value, that is 2.156 divided by its standard error, that is 0.253. Clicking on OK. So the value is 8.5217. So how we will interpret this particular value? So for interpreting this particular value, I am coming to the slide again. You can see here in the slide, I have written here, if the in our case, it is 8 point something. So we can say that there is a significant skewness at alpha equals to 5%. If this value is greater than 2.58, we can say there is a significant skewness in case of or at the 1% level of significance or 1% alpha value. If the obtained significance value is greater than 3.98, we can say that at 99.9% there is a significant skewness in the data set. So whether we are taking 5% or 99% or 99.9%, whatever case we can take here, in each and every case, our significance level of skewness value is greater than the desired values. So again, these values are indicating us that there is a positive skewness there in the data set. With the help of significance significance level of skewness, we can test the claims of the companies as well. For example, some company is claiming that one of the outlet is performing well in terms of that the salesmen of the outlet are able to sales, for example, car at the higher price as compared to the mean value, or the higher price compared to the mean value. So we can check their claim that whether their claim is significant or not. How? With the help of significance level of skewness. With the help of this particular value, we can calculate whether the particular claim is significant or not. So this way we can calculate significance level. Then moving towards the last point, that is the kurtosis. Kurtosis value is 5.080 in case of automobile sales. Again, this is the positive value. So this is indicating us there is a that means that data is not normally distributed. First of all, I need to show you the PPTs. I think that then you will be able to see. See, this is the kurtosis. You can see there are three graphs are in the slide. Middle one is the normal distributed or the normal curve. This is the standard curve, but the blue one is the leptokurtic curve. This indicates that there is a positive kurtosis in the data, and this is the flattened enough, and this indicates the negative kurtosis in the data set, and it is known as platykurtic data. So with the help of sign, if the sign is positive, then we can say our data is leptokurtic. If sign is negative, we can say data is platykurtic. Here in our case, the sign is positive for the value of kurtosis, that is 5.080. So we can say there is a positive that the particular data set has leptokurtic kurtosis available in the data set. So means after reviewing all these things, that is median value, variance, standard deviation, interquartile range, skewness, and kurtosis, everything, these all are indicating us that data is not normally distributed. So if data is not normally distributed, in that case, we should not report the mean value. In that case, we need to report the median value. So this is the thumb rule. If data is not normally distributed, we need to report the median value. And suppose if data is normally distributed, in that case, we can report mean value. So this is from my part. If you want to ask something, you can ask.
Ma'am, I have a question actually.
Repeat last line. Ma'am, repeat last line.
Yes, I'm repeating. If data is not normal, after we have checked here that data is not normal, with the help of interquartile range we have checked, with the help of trimmed mean we have checked, with the help of median and mean value we have checked, with the help of skewness and kurtosis value we have checked that data is not normal. Either it is positively not normal, means it can be either positively skewed or negatively skewed. It is not the normal data. So in that case, we need to report the median value. If data is normally distributed, in that case, we can report mean value. So this is all from my side.
Thank you, ma'am.
Ma'am, thank you, ma'am. Ma'am, good evening. I actually wanted to ask the question that you said that if the data is not normally distributed, I have to report a median value.
Yes.
Ma'am, does this mean that I cannot draw any conclusion with the help of mean if my data is not normally distributed?
Yes, correct. Means that in that case, it can lead to the false conclusion.
Okay, ma'am. So if I have to say like which, if I compare two data and like I have to say which particular data, has higher respondent or something, I have to check my median. Whichever has a higher median is the one that has a higher respondents like.
No, you need to check, ma'am, for normality, you need to check kurtosis, skewness, mean, median, mode values, and interquartile range. On the basis of that, we can say data is normal or not normal. Standardly, I will tell you, if mean, median, and mode, all three values are almost similar, then we can say that is one, means there are certain assumptions or there are certain criteria. After following all those criteria, we can say data is normally distributed. So from all those criteria, one criteria is mean, median, and mode should be equal. Second one is skewness should range from -2 to +2. Third one, kurtosis should range from +3 to -3 to +3. Standard deviation should be around 1. So if all the criteria are followed by any data, so we can say data is normally distributed. If data is not normally distributed, in that case, we cannot go for the parametric test. We need to go we need to check for the parametric test. We can think for the parametric test in those cases.
Hello.
Yes, ma'am.
Ma'am, this parametric, non-parametric, can you just repeat once again?
Which one, ma'am?
Just now
Shapiro.
you were answering, right? So
Shapiro.
no, when the data is normally distributed, we go
Yeah.
for parametric, right? And when the data
Yeah.
is not
Not
normally
normally
distributed,
distributed. That
we have,
means we are, if again, ma'am, suppose data is not normally distributed, and again, suppose we are going for the parametric test. Suppose I am applying t-test or ANOVA. That means we are violating the normality rules. And because these tests are first criteria for applying these tests is the data should be normally distributed. If data is not normally distributed, and again we are applying different types of parametric tests, then they will give us the false conclusion. Whatever data we will or whatever result we will interpret it, we will report that is not reliable one.
okay. My another question is, suppose like as a thumb whenever we are writing a paper, so we start with the testing of normality. We understand whether it is normally or whether it is normal or not normally
Not
distributed.
normal.
Then we decide
Accordingly,
for the test.
accordingly we can select the test.
Yes, and also, do we have to report the normality details in every paper?
I think it will be good, ma'am. If you are showing that whatever data you have collected and it is not normally distributed, that is why you are switching for the non-parametric test. That will give a good impression.
Okay, thank you, ma'am.
Yeah, yeah.
Very well explained.
Thank you.
Ma'am, over here, ma'am, as you have done in this particular normality test, you had taken two characteristics like sales of truck and automobile, right? So, ma'am,
Automobile.
if I want to check the whole data's normality, then I have to select the all question like question 1 to question 21. I have to select all the question and then I will check normality.
Yeah, but ma'am, I will suggest you one thing, because we work on hypothesis, right?
Yes.
And in hypothesis, generally there are two variables, dependent and independent. So I
Yes,
think
ma'am.
at that particular time we can check the normality for these two. This is my suggestion. Otherwise, you need to go one by one and check the normality of the data.
Okay, ma'am. And along with that, ma'am, see, so in some data we could find that they are the normal data and they have crossed the normality data, normality Cronbach alpha test and all one. But some data are like non-parametric, and we are applying that like we are applying chi-square test, right? But if in one particular research we may apply both the things, normal distribution in some area and non-parametric test in another, we can apply it or not?
You mean to say, first of all, ma'am, you need to check the normality of the data, right?
Yes.
If
Yes.
data is normal, we can go
Yes.
with any kind of test. It's
But
totally
ma'am,
up to you. You want to go for the parametric test or non-parametric test. But for I mean to say, for parametric test, it is the compulsorily we need to check the normality. If data is not normally distributed, we cannot apply the parametric test. But if data is normally distributed, then we can go with
yes.
the non-parametric test as well. There is no
Yes.
issue.
But ma'am, whenever we are doing pilot study, like we are applying our sample, like I am from HR background and we are taking 100 samples and we analyze all these things. So in 100, I have a 31 question. In 31 question, in which which is connected with my hypothesis, and like in 5 special variable there is a normal distribution. It is proven. So I will check there and I will apply that parametric test at that. But in latter 5, that is